Thank you, Umid, for introduction. So today I've got the pleasure, guys, to talk to you a little bit about continuous learning systems. So actually, the system that kind of helps keep your model up to date on production. Okay. So first, let me tell a little bit more about the team actually I'm working in. So we are part of the Krakow Software Laboratory, IBM ones, located at Army Croway Street. You can see the Galileo building here actually. So we are working on Watson machine learning service on public cloud. So I'm kind of leading the data science team, but the whole team kind of consists of the software developer, data scientists, and DevOps engineers. So Umid was part of the data science team. However, he decided to leave and join the elite team now. Hopefully, he's gonna come back quite quickly to us. So what are we doing within the project actually? So we are trying to make the data science as simple as possible, so even the primary school students can actually use it. So this is, I would say, the first aspect of the project: make the data science, because we got the domain knowledge, as easy as possible as a product on the cloud for the users who doesn't want to get dirty with the data science job, but would like to put some kind of predictive mechanisms in their applications. So this is one thing. And the other thing is actually, which is probably more even important than making a model, because a lot of people are making models right now using the open source, is how to move this model from the local machine or cloud environment to production environment, where we actually can get some kind of benefits from it. How to make it available to our system, web application, to get any insights it produced and reuse it to actually support some kind of business or business decisions. And yeah, you probably heard everyone is right now talking about the data science, data scientists. So I just grew up a really nice definition who data scientist person is. It was present on Twitter. So you can read it right now. So basically, the data scientist is a person who is better at software engineering than the statistician, and in the same time, better at software engineering than better at statistics than the regular software engineer. So you probably can find right now that the data science position is being kind of told being the sexiest job offering in 21st century. So hopefully, Krakow gonna be such data science hub in the close future. Right now, it's being recognized as IT hub, but let's hope that's gonna be changed as well. Okay, the CardioCube. So the CardioCube is a startup company which was started by the cardiologist and his friends. So actually, we had a pleasure to meet with them twice. Last year and that year. So they kind of figure out that there is a gap on the market, that the people after the heart disease that actually left the hospitals very often are coming back to the hospital because they were not treating themselves well. So they decided actually to attack the market with the device that actually asks the patient at home about his condition, and the answer actually are being transformed to the application that the cardiologist, the doctor, actually has in his own office. So he's actually able to monitor the patient's state without seeing him or her on regular basis. So as far as I know, they right now are running a pilot of that product in some cardiology clinics in Europe. So what actually they wanted from us? So they actually came to us with the question how they can move it to the next level by adopting more advanced machine learning algorithms within this product. So what I'm going to show today actually is a demo I prepared for them, basically to showcase how easily it can be extended with the predictive power. So it actually happened that we got a data which is in the same domain. So we got the data of the patients which we were actually examined with the 5 different drugs, and the goal actually is to predict the best drug to particular patient based on the patient condition. What kind of data I'm talking about? So the data is actually quite simple. As you can see, it consists only of 1, 2, 3, 4, 5, 6 features. So you got the age of the patient, sex of the patient, blood pressure, cholesterol, sodium, potassium, and the drug. The drug column actually is the label or target column, whatever we name it, the one we actually try to predict. So you can actually find some kind of, I would say, adoption of such data as the next step of the CardioCube product extension. So for example, depending on the patient state, that kind of communicated to the device and also some kind of feedback from the doctor can adjust the drugs the patient is taking at this moment. Okay, so we got a model. Actually, we don't have a model, so let me just try to make one quite quickly. Okay guys, so yeah, so I got the data in the database, cloud database. So I have connected actually to that. I have put out the data. I have put it into Spark data frame. You can see the preview of the data frame on the screen. So what I'm doing right now, I'm gonna split the data quite easily to the two subsets, train and test data. Train data are gonna be used to train a really simple model, and the test data are gonna be used to evaluate that model later. So you can see the split ratio as 80 and 20%. Next, we are importing some packages from the PySpark. So actually, I'm using a Spark MLlib library here. I think most of the folks here were actually showing and kind of talking about the Spark. Next, I'm using transformers. There was a pretty cool speech about the Spark MLlib pipeline. So basically, the pipelines consist of the transformers and the estimator, which is actually classifier. So I'm using a really simple transformers here, which are actually string indexers. So they are used to kind of transform the string data, like for example, sex, which is male or female, into the numerical data. Okay. Next, we got a vector assembler, which is another transformer which actually puts all feature into a single vector. Let me run it. And finally, we got the estimator, which is actually classifier. In that case, we are using decision tree classifier. We just provide the name of the label column and the name of the feature columns that have been vectorized in the cell above. And finally, there's one more additional step, which is actually optional. This is a label converter. So we actually do the vice versa operation because we have transformed the drug name to the numerical values. And at the end, we'd like to have a really nice prediction drug name. So we do the operation to transform it back to the string. Okay, and we are building the pipeline. So exactly the same pipeline everyone was mentioning here. So the pipeline consists of the stages, as we can see here. Maybe I can make it bigger. Yeah, I think I had a comment about that. Sorry, Rafa, I forgot about it. So we are adding the stages, and we are adding the estimator and the label converter at the end. So we got the pipeline created. And next, we train this pipeline by passing to it the training data we have created by splitting the original data into two subsets. Okay, it's gonna take, actually it's quite quick. And finally, we'd like to see how good or bad our model is. This is a very basic model, but we achieve 87% of accuracy, which is no shame actually. Of course, we can do some parameters tuning, we can check different classification algorithms and so on to tune it, but for the example I'm going to show, it doesn't actually matter. Okay, so we got a model train. Now we'd like to push it to the Watson Machine Learning Cloud service, so we could do more cool stuff with that later. So we are just grabbing a Python library, which is available on PyPy, so you can play with that if you'd like to. Credentials to the service. We are authenticating to the service. We are preparing some metadata. I'm not going to go to much details, but we are just providing the name of the model. We can add here, for example, so you know, like a cool one. And we are providing information about the initial model quality we have calculated above. And we store the model by basically calling repository store model method. So what's kind of important here, we are not only storing a model itself, but we are also passing the pipeline. It's important because we will need it later. Okay, so we can also list all the models we got in the Watson machine learning service instance we are working with. By calling the list models method. So we can see that the model we have just trained, it's the last one on the list, is present there. Okay, so we are actually done with the first part. So let me go back to the okay. So I have a model. We got a model actually. We have just created it. Okay. So what next? So we got a model, but what we actually we want this application be present at doctor office, so he could do the predictions, and he could also send a feedback about the predictions. You don't see it. This is at the bottom actually here. I'm gonna show it later. So what we need actually to move from the application. So we need several elements here. We need a collaboration between a data scientist, software developer, and probably some DevOps engineer who will put everything in place. Is it easy? Maybe or maybe not. So I have heard a story about the use case when the software developer was asked to take a shiny app from the data scientist and make it a production application. So after some time, I have heard a comment in the kitchen. Heck, I've been handling 2000 lines of the Python code that queries a local DB installed on the laptop with no comments and documentation, and been told to make it work on production. So as you can see, it may be easy or maybe not. Then we need a deployment capability. So we got the model, but we actually don't care about this model. We care about the served model, which, for example, serves as a web service. So we can go from the app to that model, send a new record, and get the predictions back. We need a monitoring actually, because we want to know how good our model on production is. We don't want to have a model which actually shows quite good accuracy on the test data set, but the scoring data set which comes to that model brings and provides us predictions that are completely out of date. For example, the seasonal data was used to train a model, and different data comes to the scoring endpoint. We need to have a retraining capabilities. We got new data, which is labeled data, which we call feedback data. We want the model to reuse the data to retrain automatically, so it shows the best available predictions to the application the doctor at the office is currently using. And of course, it also comes with the redeployment capabilities. So if the new refreshed model is better than the previously deployed one, we want to refresh it on the fly. We can skip this slide actually. So, okay. So we got our model actually. So what we are missing right now is this model deployment. So whatever I'm showing right now using Watson Studio and UI, you can do either using REST API, CLI, or Python client library. So we can go to the deployments tab, and we can easily deploy this model. We just provide some name here and press save. So we can see that the model I have just created is being deployed as a web service. It's done. 30 seconds. We can go into deployments details because my model is deployed, but I don't believe actually in that, so I need to try it out, check if it's deployed correctly. So I can go to the test tab. I can provide some sample scoring record. So let's say 55 years old, male, BP high, cholesterol high, let's say 0.6, 0.04. What it does actually, it grabs this sample scoring record, transforms it into JSON payload, sends to the deployed model scoring endpoint, and in return gives me the predicted drug, which is drug Y in that case. So it looks like my model has been deployed correctly. I'm able to work with it. I'm able to send a scoring records, and I'm able to get the scoring results, which is actually the prediction. So what I'm missing the monitoring part, retraining part, and redeployment part. So let's go back to my model again. I've got the evaluation tab. I see that the initial accuracy of my model was above 0.8, above 80%. So I can easily configure some additional performance monitoring capabilities. So this is a Spark model, so it's being run on the Spark cluster. I see that the problem I'm solving is multi-class. I can select a metric, which I can use actually to monitor my model. I have started with the accuracy, so I'm selecting accuracy, but you can select multiple metrics as well. I can set up some threshold. So what the threshold actually means, it means that some action should be triggered if my model accuracy is below that threshold. And now is the feedback part. So I need to connect a feedback data store. So what the feedback actually is, so let's say that we have trained a model on some data set, and this model is put on the production. So after some time, new records gonna be collected, the records which are actually labeled records. So those records can be sent to the feedback data store, either using a REST API, Python client, or CLI. So they can be reused to actually evaluate our model on the production and retrain it later. So let me just select a source for that. So just before the meeting, actually, I have uploaded few records to the cloud database just to demonstrate it to you. Okay, there's one, DataSphere. I can select it. Okay, there's around 50 records. And now we got two options, auto retrain and auto deploy. So we can decide what actions should be taken when the threshold is not met. So we can actually auto retrain the model when the model performance is below specified threshold. So we can do actually nothing, and we can also retrain it always. So let's go with the smarter way. And also the same with the auto deploy. So we can deploy when the new version of the model, the retrain one, is better than the previously deployed one. We can always deploy fresh model version, or we can do actually nothing about it. So let's go with the smart option. Let's save the configuration. So what we currently see actually is only the threshold we have specified on the chart, which is 0.8. And we can see the setup point, the initial point. So this is actually the quality of the model we have created in Jupyter Notebook. We can see the accuracy at level 0.871, threshold 0.8, and the phase is called setup. So what we can do right now, we can actually trigger the whole process. This is run on the Spark cluster, so we can see right now that the kernel is being started. The data is being loaded, the training data. Now the feedback data has been loaded as well. The model is being evaluated. You can see it, yeah, here. So the data that didn't take part in the model training is being used to evaluate a model on production. If the evaluation result gonna be below specified threshold, the retraining gonna be triggered. If retrain version gonna be, you see retrain model action right now. And right now we can see that the model is being, the new version of the model is being validated. If it's better than the previous one, it's gonna be redeployed. So for the new version of the model, we use cross-validation with 3 or 5 folds, I don't remember right now. Okay, we are done. So we can see that new version of the model has been deployed, and we can see on the chart actually what happened here. So this is where we started. So this was our original model with accuracy above 0.8. We gather new feedback data. We use it to monitor our model on the production. So we can see that the accuracy of the model went below specified threshold, 0.75. That triggered the retraining action. The retraining action actually pulled out the original training data, the feedback data, used both of them to retrain a model. Next, it used the cross-validation to check how good the new version of the model is. So we can see that the retrained model accuracy is again above 0.8, and because of that it has been redeployed. You can see the same in the table form. So this was the original model and its accuracy. This was the model accuracy after the monitoring stage, when we use the feedback data to check how good our model on production is. And this is the model accuracy after retraining. And you can see this green icon on the right. It basically means that new version has been redeployed. We can see both versions. If there are any reasons why we do not want to deploy this new version, we can always go back to the previous one by choosing the action menu to actually do that. Okay guys, so we got our model created, we got our model monitored, we got our model retrained if needed, and we got our model redeployed if needed. So what we are missing right now is this front-end application that actually takes those predictions from the deployed model and makes some value of that. So actually I've got the sample application somewhere. Let me just go to the IBM cloud. Oops. Where's sign? Let me do that. Yeah, it takes some time, sorry for that, but we are almost there. Okay. Yeah, so I'm basically using IBM Cloud to host my Node.js application that is integrated with the Watson Machine Learning Service instance, the one I was using before, to train my model, to deploy my model, to monitor it, retrain and redeploy. So right now I'm just trying, at least I'm trying to yeah, it's really slow. Okay. Okay, so this is the sample application I was talking about. So this application basically detects my model deployments. So I got a previously created one, like it's called drug deployment. It has 8 patient records with the different names and some features, the one you saw before. So like blood pressure and so on. So you can basically select one of the patient record, and in a response you got the prediction of the model we have just deployed. And what's the best of that actually is that you can also send a feedback if you think that the predicted drug for this particular patient condition is not the best one. You can send a feedback by pressing one of those buttons, and what's gonna happen actually is that the new training feedback record gonna be stored in your feedback data store, and next time when the model gonna be monitored, it's gonna be used. The same for retraining. So that's actually basically all I had to show guys today. So thank you for attention. I think only the strongest survived.
Thank you, Chris. All right, any questions? Let me see. Okay, coming there.
Yeah, thanks for that. We talked about that a little bit offline, I guess. But if you had a case, as we had with this sales forecasting, where you have loads of models, so a model per store, and you have like hundreds of stores, let's say, how would you do that? Because it sounded to me that you just defined one model, right, for one case. Is there a way you can sort of define multiple models based on some filter, let's say, on the data?
Yeah, so there are two things actually. The first thing is actually building multiple models, but this is probably not the case you are talking about. You are talking about serving multiple models at once.
First building, because they will be different, and then serving as well, yeah.
So so if the models are different, actually there is no way to build them actually at once, because they differ either in the actually the use case may be different, the data format may be different, so unfortunately you need to build them probably one by one if they differ. But for the second part, actually, when we are talking about deployment, so there is a feature we are planning to add. I think we can at least mention it. This is like a model grouping. So you can deploy a whole group of the models instead of single one, and you can add some kind of mechanism to that, like for example A/B testing, as we mentioned. So for example, the best one of them gonna serve a request at particular period of time, or few of them gonna serve the request, and the result can be sent to another model to kind of create some kind of assembling or stuff like that. So that will make that stuff much easier when you can think about the group of the models, cluster of the models, not a single model. But not yet. Hopefully this year. We'll see.
Okay. Maybe another one from me. I'm not sure if I'm hogging the time or not, but so are you planning also to, because you have this feature where it checks, evaluates the model as it goes and then retrains the model. Were you also thinking about adding a feature where it does this sort of online continuous learning? That is, you know, every new piece of data that comes in actually retrains the model a little bit. Obviously, not all the models can be trained in that way, but some of them could.
Yeah, so right now it is limited by the minimal number of records that has to be kind of stored in the feedback data store. I put there 40, but if you put there only one, it's gonna trigger even if you got only one record, the training process. The problem with that is that sometimes the training may be quite expensive. So you may not want to trigger the training process each time new record actually comes to your database. But this is up to you, up to your use case, and up to your needs actually. Yeah. So there's no at this moment software limitation if you'd like to do it right away if the single record comes to the database.
Okay, cool. Cheers.
Yeah. So one more addition to that. So you were asking about the online learning, like updating, I think, the model parameters. Yeah, as every time that data arrives. So so this is, I think, that is among the discussions that, you know, we are always having with the architecture team. Of course, it depends on the use case and the need. And what Łukasz was referring about model grouping, I mean, there are no limits on the number of deployments today. You can deploy as many models that you want. But what Łukasz was referring, that this model grouping and the A/B testing will make it much more easier to manage once you have multiple deployments. So it's just an additional like improvement feature. Right? Okay. Any other questions? Okay, so thank you very much, Łukasz, once again for the demo. It was great presentation.
Yeah.